In this video, I'm going to show the image of why we have a high demand for SerDes IPs. Again, the SerDes IP are used for high-speed data transmission between chips at either short distance or long distance. Going through a few applications will provide a few usage images for you more clearly. For the SerDes related trends in the Semiconductor Act, the US Congress signed $52 billion for the semiconductor last year. Also, the IDC has announced the amount of our data usage will reach 175 zettabytes in 2025, which is very impressive. Let's see why we would need so much data usage in the world. Even though we are talking about the wireline transmission, the 5G wireless trend will still depend on the SerDes. If you recognize lots of functionality inside your smartphone, that should be obvious. They will transfer lots of data to the baseband unit. Therefore, the SerDes is a must. In addition, lots of digital signal processing will need the SerDes for data exchange as well. Since the amount of data is increased, we may need a higher data rate in every standard protocol. In CP, the data rate requires 56 gigabit per second from 12 gigabit per second in the past. In JSG 204 and PCIe, people already push the data rate up to 32 gigabit per second now. That's for the 5G. How about our wireline system? The most obvious wireline system is the Ethernet, owing to a high demand in the data center driven by cloud computing or AI. The speed requirement will reach 1.6 terabits Ethernet. Another interesting picture of the data center room comparison is very messy in 2009, but must be clean and well organized nowadays owing to the SerDes or SerDes, which we already show you in the Why SerDes video. Another very important interface in a computing system is the Peripheral Component Interconnect Express. It's an interface standard for connecting high-speed input-output HSIO components. Every high-performance computer motherboard has several PCIe slots you can use to add GPUs, RAID cards, Wi-Fi cards, or solid-state drive SSD add-on cards for data computation. Back in the old day in 1995, the PCI bandwidth only 33 megabit per second times 4 or 8, but today's PCI 5 would have bandwidth up to 32 gigabit per second times 16, which is 2,000 more throughput now. In addition to the consumer electronics, another recent popular application of the data transmission is the automotive industry, driven by the demand of safety assistance or self-driving. Lots of data must be exchanged and processed. Therefore, the speed requirements are increased to 10 gigabit per second in automotive Ethernet, 13 gigabit per second in ASA, and 48 gigabit per second in MIPI. Besides the imaging application, what's the other new SerDes application? As you know, the requirements for the data amount are increased, and then driven the chip capacity of the data processing quite a big. Therefore, the chip size of the SoC will become bigger and bigger, which will be a challenge for manufacturing. For example, a bigger size of the chip area will lead to a lower manufacturing yield. To mitigate the manufacturing yield issue, people think about the system in package SIP instead of a system on chip SoC. Therefore, the monolithic wires are replaced by cross-package die-to-die interconnect, and the SerDes for the die-to-die D2D interface is a must. Since the D2D SerDes is for chip integration, do you see any constraint on it? Think about the PPA images for 5 seconds. Correct, the D2D SerDes need to provide enough data throughput at the interface. Therefore, it must be high speed. In addition, it only provides flexibility of the integration between different chips, and low power overhead is a must. Similarly, not only helps the integration, but also reduce the cost. A smaller area is very critical. Because of those constraints, the D2D SerDes are very changed in the PPA images. In addition to the yield improvement, do you see any idea of another benefit of the SIP by leveraging the D2D SerDes? Think about the process images for 5 seconds. Bingo! In addition to the design capacity of a chip driven by market or industry needs, all the technology or process node variants are so different between different foundries like TSMC, UMC, Intel, Global Foundry, and so on. Furthermore, different process nodes in 180 nm, 20 nm, 3 nm, and 2 nm could be much different in the device structure, such as planar, SOI, FinFET, and gate-all-around nanosheet devices. Therefore, the SerDes IP porting effort or risk is much higher than before. Also, the ergo SerDes performance might not be benefit a lot like the digital circuit. What can we do? Think about the SIP images for 5 seconds. Correct. The SIP would also speed up the time to market as TTM. The SIP may remove the constraint of the same process node in a SoC. Again, porting the ergo SerDes I/O toward the most advanced process node as the digital circuit does not improve the ergo performance, but also add more risk on the ergo IPs. So, the D2D SerDes does help the second-proof IP from different processes integrated in one SoC. For example, the second-proof IP might not be available in 3 nm like the CPU or GPU, which is okay, since we still can use other second-proof IP in an older process node like the 16 nm SerDes I/O to benefit from the best performance and low cost. Here is the summarized image of why we have a high demand for SerDes IP. First, the growth rate of the semiconductor is quite high. Then, even the 5G wireless network would need a high demand for SerDes. Not to mention the wireless communication. The wireline communication such as Ethernet, peripheral component interconnect, or even the automotive industry, etc., require lots of SerDes IP to keep the manufacturing yield while increasing the chip capacity. The new SIP approach will even need a lot of die-to-die SerDes I/O to help the chip integration. The new SIP will help the ecosystem shorten the time to market and reduce the cost quite a lot. Therefore, those industrial applications will push more and more SerDes IP demand in the future. I hope more and more circuit designers can contribute to the high coming demand of the SerDes IP in the future as well. Thanks for watching. Before you go, if you are benefiting from those circuit images, I would love to hear your feedback and please share your comments down below. Lastly, please share the video link with the people who may be benefiting from it.